Hello, guys. Okay, so we're going to start off. This is 811, and we're talking about the changing dimensions, the effects of changing dimensions on figures. So the first example, what do you think will happen to the volume of a cylinder if you double its height? In this blank where I have your thoughts, write down, well, what are your thoughts? What do you think will happen? Now what we're going to do is we're going to use some test numbers to see what actually happens. Okay, so we're going to use our volume formula. I'm not going to use this color because that doesn't come up very well. So the volume formula for a cylinder is pi r squared h. We're going to make our radius for the original be 1 and the height equal 1. Why not make it simple? Okay. So to find the volume, that means I'm going to be doing pi times 1 squared times 1, which is going to give me that my volume is pi, because 1 squared is 1 times 1 is 1, so it's just left with pi. Now, what we're doing here is it's telling me double its height. So that means my scale factor is 2. All right. So we plug this in. So now we have that the radius is still 1, but now my height is 2 because it's doubled its height. Okay, so now we plug in and we're going to have 1 squared times 2. So that's going to give me 2 pi as my volume. Well, to notice what happens between the two of these, you'll notice easily it doubles, but you can also calculate this by doing the new over the old. We have 2 pi over pi. The pi's cancel, and I'm left with 2. This tells me how much it changes. How much it changes. So therefore, how does the new volume compare to the old volume? It's doubled. Remember, I know you can see this real quickly here, but I'm trying to teach you how do you figure it out when it's a more difficult problem. Okay. Next, we're talking about the volume of the cylinder, excuse me, if you double its radius. Now, this is where it throws a curveball because we've got to remember that the volume formula, oh, here again, you write your thoughts of what you think is going to happen there. The formula is pi r squared times the height. So again, we're going to just plug in numbers. So we're going to have that the radius equals 1, the height equals 1. So therefore, we have pi times 1 squared times 1, which gives me that my volume is pi. But we're going to see the difference here is the new. So this is my new one. This is my old one. Okay. This is old. This is new. So we're going to have, so for the new volume, it's doubling the radius. So therefore, we're going to have pi times, now my radius is equal to 2. My height is equal to 1. So I have 2 squared times 1. So therefore, that's going to be pi times 4 times 1. So this is 4 pi is what my new volume is. So when I do my calculation of new over old, I see that I end up with 4 pi over pi. The pi's cancel, and I'm left with 4. So therefore, it is 4 times bigger. Another way you can kind of look at that is, well, what happened? Scale factor here is doubled. I did the radius squared, which is 2 squared, which gives me this 4 again, okay? Which shows that is 4 times bigger. Up here, we only changed the height. We only multiplied by 2 one time. So therefore, it's just the height that changed. So therefore, we just multiplied the volume times 2 one time. Whereas here, it's multiplying times 2 twice. Okay, moving right along. Let me angle this versus move the paper up. It makes it a little bit easier. Okay, looking at number 3. How does the volume of a cone change if the radius is tripled? Okay, so for the volume of a cone, excuse me, remember that is 1/3 pi r squared times the height. So we're saying that the radius is going to become 3. The height we're going to keep as 1. And in our old one, the old is always going to have a radius of 1, a height of 1. Make it simple. So I'm going to see, okay, so this is going to be just, that's all going to become 1s. So it's 1/3 pi times 1 squared times 1. So that's 1/3 pi. For the new volume, it's 1/3 pi times 3 squared times 1. So that's 1/3 pi times 9, which then if I look at that, that means this 3 becomes a 1, this 9 becomes a 3. So therefore, the new volume is 3 pi. Now, again, when we're doing this, to calculate how many times bigger, we do the new over the old, which means I'm going to be doing 3 pi over 1/3 pi, which means the pi's cancel. But now I'm left with 3 divided by 1/3, which is the same as 3 times 3, which gives me 9. Now, the thing is, I can also think about working this. It's a lot of calculations, but if you can figure it out and realize the radius is tripled, that means it's going to be the scale factor, because when I'm looking at this, the radius is tripled, so my radius is going to become 3, so therefore this is going to be 3 squared, which is 9. Notice I see that 9 right here. So therefore, I can automatically say, notice this is the same as this, that this is 9 times bigger. Let's look at this a little bit of a different way for the next one. Okay. Now, this is how does the volume of a square pyramid change? Now that's a square. Square. The base edge is multiplied by 6. So that means my scale factor is 6. That's what I'm having to multiply by. But what you have to remember is a square and it's a pyramid, that means my volume is still 1/3 capital B times H. But the thing I've got to remember, that capital B is calculated as S squared because it's a square. So therefore, to figure out how many times bigger, I'm going to take the scale factor and I'm going to square it, which is going to give me, I'm trying to figure out how, because there's such a glare from what's going on right now. The scale factor is 6 squared, which gives me 36. So therefore, I could say this is 36 times bigger, because that's what's changing, because remember, the original is always being treated as 1. For the old, the side is 1, and the height is 1. So therefore, it's just still going to be 1/3. The original volume. The old volume would be 1/3, because we're doing 1 squared times 1. So it's just 1/3. The new volume is going to be 1/3 times 6 squared times 1. The only thing that's changing is this 6 squared, which is 36. So therefore, that further confirms that this is just 36 times bigger. Next. Okay, we're moving on and we're going to look at number 6. Now we're going to talk about surface area. Surface area of a sphere changes the radius. So when we're talking about surface area, we're going to have to take that formula into consideration. We're saying the radius is multiplied by 1/2. Okay, so for the surface area, that formula is 4 pi r squared. So again, for the old, my radius 1. So therefore, let's make it easier because we get to choose our numbers. Let's make the radius 2 for the old, and for the new, we'll make the radius equal 1. So therefore, when I figure this out, my radius is equal to 2 here. That's 4 pi 2 squared, which is 4 pi times 4, which gives me 16 pi as the surface area. Now, that was the old. Now we're looking at the new, because it's multiplied by 1/2. So therefore, we're going to be, to find the surface area, we're going to do 4 pi times 1 squared. Because remember, for this, we said the radius would equal 1. So that means we just have that the surface area is 4 pi. Well, to calculate how it's changed, remember we do the new over the old. So therefore, I'm doing 4 pi over 16 pi. The pi's cancel, and I'm left with 4 over 16, which simplifies to 1/4. Now, let's look at the other method. Since this is the scale factor, it's the radius that is multiplied by 1/2. And notice the radius is squared. So we could have radius squared, which is going to be 1/2, because that's kind of the scale factor. That's what's happening. So we're doing 1/2 squared, which gives you 1/4. So therefore, it's 1/4 as large. You can choose whichever method. You've just got to justify both. Okay. So here it's the radius is squared. My scale factor is 1/2. All right. Moving on, we're going to jump down and we're going to talk about number 10. This is where we're finding new measures. Okay, so it says the volume of a cone. So that means I'm using, it doesn't matter because it's if the radius is multiplied, so we're just doing the radius is multiplied by 1/2. What will be the new volume of the cone? Well, that's where we do have to remember what's our formula. It's 1/3 pi r squared times the height. My radius is squared in this instance. So what we can do is we can take the original and multiply by the scale factor squared. Okay, and it's because r, the radius is squared. So we're going to do 864 times, it's multiplied by 1/2, so this is my scale factor. So it's 1/4, no, not one. It's not 1/4, it's 1/2. I get 1/4. Jumping ahead. 1/2 squared, which gives me 864 times 1/4, which is pretty much the same as 864 divided by 4. So I'm going to have, I can do that over here. 4 into 864. That's 2, 6, 3. No, 1. Kimberly, wake up. 24. So it's 216. So 216 centimeters cubed is the new volume. Okay. Remember, pause, rewatch, and ask questions as needed. Have a great day.